Hello everybody. Well, we made it through Unit 3, all right, so we'll be done talking about quadratics for, well, unless you see them on your weekly. All right, so we're going to start a new chapter, and it's going to be Unit 4, Day 1, Exponent Rules, okay? So make sure you got that out or you're taking notes while I'm going through this, okay? So some of this, hopefully, is a little bit review, right? Now, we're going to be getting a little crazy with some of these exponent problems. We're going to be simplifying them, right? A lot of times you don't encounter, numbers like this, but, just like when we're factoring, right, when we're going through that factoring unit, okay, a lot of times we're doing some of these real obnoxious looking problems because we want to make sure that you guys got the process down, okay? So the process doesn't change, okay? It's just a matter of being able to understand the rules and being able to simplify things based off of these rules here, just like factoring, okay? So the problems aren't going to be as lengthy as those factoring chapter, okay? So don't get nervous about that. But, however, like I said, we're going to see some heavier, exponents problems that we're going to have to simplify, okay? So before we can get to those, we have to start with the basics, right? The rules, right? And like I said, some of you guys might have forgotten some of these. So hopefully it's not totally something new. Hopefully it's a little bit of review in the sense that maybe you just kind of forgotten some of these rules, okay? So anyway, multiplication of powers with the same base, right? So when you have the same base, right, what do? We just add the exponents, okay? So over here, we got x cubed times x to the 4th, and that's just x to the 7th. Okay, and if you think about it, right, really what we're doing, because we don't know what x is, right, we're just basically counting how many x's we see here, right? So how many x's do we see? We see 7, okay, and so that's why we kind of add them up. And we're adding how many x's we see. Now, this one, right, kind of opposite, right? When we multiply, we add. When we divide, we are going to not add the exponents, we're going to subtract them, okay? And so here's a quick example. 3, 4, 5, 6, 7, all over 3 x's, right? Okay, and so we cancel out 1, 1, 2, 2, 3, 3. How many x's do we have left? 4, right? And so 7 minus 3, well, that's x to the 4th. Okay, so those are our first two rules. The next one, power to a power. So anytime you got something raised to a power and it's, as you can see, we're being raised to another power, right? What you do is you just multiply those two exponents. So here we got x squared, right? Well, how many x squared cubed, right? So how many x squareds is that? Well, that's that many, right? If we were to break that out, how many x's is that? Well, that's 1, 2, 3, 4, 5, 6. So how many x's do we have here? X to the 6th power. All right, distribution over multiplication, okay? This is where students tend to make mistakes here, right? You need to make sure that this 2 squares both items inside that parenthesis. Okay, so when you get over here, right, we're going to make sure that we square the 4 and we square the n. And so we end up getting 16 n squared. How about the next one? All right, well, same thing with multiplication. All right, we're going to do the same thing. We're going to kind of multiply that a to all of our pieces in here again, right? So make sure that every piece of that is getting raised to that a power. So here, 3 squared over 2 squared, right? Those both go, it distributes to both the top and the bottom, and then that's just equal to 9/4. But let's take a look at what 3/2 looks like, right? Or 3/2 squared, right? So 3/2 squared is 3/2 times 3/2, right? And how do we multiply with fractions? We multiply the numerator in the numerator, denominator in the denominator. So we get 9/4, which is exactly what we had there. Okay, 0 exponent, real easy. Anything raised to the 0 power is 1. So over here, this is going to be 2 times 1 which is just 2. Okay, they love giving problems like this. They want you to put a 0 there, so make sure you don't fall for that. Okay, and then finally, last but not least, anytime you got something raised to a negative power, you put it in the denominator and you raise it to whatever power that you have there. Okay, so in all of these cases here, let me zoom in here. All right, this is going to be 1 over 2. Make my pen smaller here, raised to the 4th power. This is going to be 4 over 3, 1 over 3 squared. And this is equal to 2 raised to the negative 1 over 3 raised to the negative 1. Okay, so how do we simplify those? Well, this is just going to be 1 over 16. This is going to be 4 all over 1/9. Now remember, when we're dividing with fractions, right, we have to KFC that guy, right? So we're going to keep the first one, flip the second one, change it to multiplication, and our answer is 36. And then here, right, well, I'm going to put that over 1 over 2 all over 1 over 3. Right? Move it to the denominator. Now we raise it to that 1 power, right? But we're not going to put that 1 there. You can leave it there if you want, but I choose not to. Okay, so this is going to be 1 over 2. So keep, flip the second one, change it to multiplication. And what is our answer? 3 over 2. Okay, right here. All right, you must make sure you memorize these bad boys, okay? Multiplication over different bases with the same power, okay? It's almost like this a gets distributed here, right? So this form, or this this sort of property, okay, we use this a lot. We're going to be using this property a lot through this chapter, right? Giveth and taking it back, right? So this is clearly the same thing over here, right? These two things are equal, except, you know, this one over here is just a simplified version, right? So just keep in mind that these two things are equal, right? And we're going to be using this sort of property to kind of mix and match things here, right? But anyway, so over here, right, 2 cubed times 3 cubed is really just 6 cubed, right? So we multiply the 2 and the 3, which gives us a 6, and raise it to that power. Okay? So, that being said, a simplified expression never contains negative exponents. Okay, so when we're simplifying these guys, make sure that you, anytime you encounter a negative exponent, you need to make sure you handle that using our rules up top. And then also never distribute an exponent over addition or subtraction. Right? Okay, this guy right here, all right, is okay, right? We can distribute that too, right? Because why? We are multiplying, okay? This guy to the right, though, please do not fall victim to this, okay? This is one of those ones that's going to upset Mr. K, right? Don't upset Mr. K, okay? Because it shows me that you don't understand what it means to be squared, right? A plus b squared doesn't just get these 2's distributed here, right? A plus b squared is actually, oops, not that, get out of here. A plus b, okay? That's what that is, right? And so clearly when you would multiply this out, right, we would get a squared plus ab plus b squared, and so we end up getting a squared plus 2ab plus b squared. Okay, and clearly that is not the same thing as right there. Okay? So don't fall victim to that. All right? I see students do that a lot. Please try not to. Okay? Everybody gets a couple mistakes here and there, but make sure you don't continue to. All right? Just follow this property here. Okay? You can't distribute exponents over addition or subtraction. Okay? So anyway, homework. All right? For homework, okay, I asked you guys to do the odd problems. Okay? I'm going to do the even problems in class. All right? You guys are responsible for the odd problems. Okay? So So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 homework problems. Okay? I think that's plenty manageable. But anyway, let's get into some examples, okay, so you guys can utilize this as a way to do those problems, right? So simplify this guy here, make sure that none of these have negative exponents. Okay, let's go. Okay, so I'm going to start with my x's. I'm going to multiply those together, so I'm going to get x to the 9th, and 2 times 3 is 6. Go to the next one. All right, technically this is this guy right here, right? So instead of doing that every time, let's just distribute this too. So it's going to be 4 squared, and then I'm going to multiply that 2 with that other exponent right there, which will give me x to the 6. And 4 squared is just equal to 16. Take a look at number 3. This guy here is actually 2xy, 2xy, 2xy. Okay? Now, I'm not going to ask you to do that every time, and I think that's a little redundant in the sense that you shouldn't have to, right? So it's going to be 2 cubed, x cubed, y cubed, and then 2 cubed is just 8. Take a look at number 4. Okay, we have the same base, so we're going to keep the base, and we're going to add the exponents. So we end up getting 3x plus 1. All right, let's keep going. Okay, so 5 halves, so that's going to be, or 5 tenths, that's going to be 1 half. Okay, now I'm left with x cubed divided by x to the 5th. So I subtract, so x, I have 3 minus 5, so that's going to be equal to 1 half x raised to the negative 2 power. Okay, so we can't leave it like that, right? So what do we got to do? We got to change that x to the negative second power. So I put it in the denominator, raise it to that power. Now I can multiply those two guys, and so I end up getting 1 over 2x squared. Let's take a look at the next one. Okay, as you can see, we don't have the same base, but we do have the same exponent. Okay, so using that property at the end of that first page there, I'm going to multiply those two values and then raise it to whatever that exponent is. So in this case, our answer is going to be that guy right there. All right, let's take a look at number 7. Number 7. So we're going to get 6x y to the 6th over 3 x squared y to the 4th. Okay, so 6 divided by 3, well, that's a 2. X to the 1st divided by x to the 2nd, that's going to give me 1 minus 2, x to the negative 1. And then 6 minus 4 is y squared. And so I'm left with, so I'm going to have to switch this guy. This guy is actually going to be equal to 1 over x. So my answer is going to be 2y squared over x. Take a look at the next one. So this is going to be x raised to the 0 power is 1. So I'm going to have 2 squared, which will give me x to the 4th. Number 9. Okay, this is raised to the 0 power, so that's automatically going to be a 1. And then that's really about it. All right, can't do anything else with those guys. And so there we go. Moving to the next one. All right, so we're going to have 4 squared h to the 6th power all times negative 2 cubed g to the 9th and h to the 3rd. Okay, so let's simplify things here. So 16h, whoops, not squared, to the 6th. This is going to be a negative 8, g to the 9th, h to the 3rd. And I have no idea what 16 times negative 8 is. So negative 128 h to the 9th, g to the 9th. Let's keep going. Okay, well, we have the same base, so we are going to subtract the exponents, right? So I keep the base, and we subtract the exponents. Now, in this case, they gave us some expressions, right? If this was 5, this was 3, right? We would do it that way. But unfortunately, they're trying to mess with us. But that's okay. Okay, just follow the process, right? Have the same base. Check. Okay, take the exponents, subtract them. Okay, so we end up getting 8r plus 4 minus r minus 1. So we end up getting 8. The r's cancel. 8 to the 3rd. All right, I don't know what 8 to the 3rd is. 512. Okay, that's our answer there. Make sure I did that right. Yep. Okay, let's go to the next one. Distribute that 5 there, so negative 24 to the 5th power. 6 times 5, well, that's 30. All over 8 to the 5th power. T15. Okay, so we're going to get some really big numbers. Negative 24. Whoops. Raised to the 5th power. Holy smokes. So negative 7, 9, 6, 2, 6, 2, 4. That's going to be t to the 30, all over 8 to the 5th power, just 3, 2, 7, 6, 8, T15. All right, so I'm going to go negative 7, 9, 6, 2, 6, 2, 4, divided by 32, 7, 6, 8. Okay, so we get a nice, not too bad of an answer here. So we're going to get a negative 243. And T30 divided by t to the 15th will give me t to the 15. Okay, not too bad. How many we got here? 2 more problems. All right, let's go. We'll finish this up. So, this one. This is going to be 25 x to the 6th times 9 x to the 8th. 25 times 9, 225 x to the 14. The next one over here, looks like we have the same base, so we keep the base, and when we divide, we subtract the exponents. Okay, so I'm going to distribute that negative sign. So that's going to be a negative, and this becomes a negative. And so our answer is going to be 5y x minus 5. Okay. Go down here. Again, same. Is that the same question? Okay. Huh. Oh. Okay. 2 different questions here. Very close though, right? As you can see, right? They have that 5y, but what's being raised? Not the 5y, just the y in each case. Okay, so what can cancel here? Your 5's, and you're left with y, 2x minus 3 minus x plus 2. So y is equal to 2x minus 3 minus x minus 2, which is equal to y x minus 5. Okay, so they were different, right? Because as you can see, right, the parentheses on 14 kind of enclose both the 5 and the y there. Okay, I see what they did there. And in this one, oof, okay, looks like we got fractions for exponents. That's all right. Multiply this in, multiply this in. So we're going to get 18 to the 3/4 divided by 3 to the 3/4. Okay, so again, ooh, this is a good one. All right, now, we don't have the same base, right? 18 and 3 are definitely not the same base. But what do we have in common? We got this guy right here, right? So I'm going to take that, and I'm going to bust it out to the outside. And so what's 18 divided by 3? 6 to the 3/4. Okay, so kind of like with the multiplication rule, except it's division, right? But the process is still the same, okay? Multiplication over different bases. Okay, even though we have different bases here, I was able to take that 3/4 out, right? And anyway, okay. So, that being said, all right, good luck with these, you guys. That's the lesson. And if you're watching this, you probably missed class, or you maybe need some refreshers on this stuff. Okay, so you are responsible for the odd problems. That is 9 problems total. And good luck.